something?
You can, go ahead. Alright guys, today we're going to start talking about our division properties of exponents. The first half of the week we did our multiplication properties. So today we're going to start division. Okay, so the first box, we're talking about quotient of powers. Okay, so let's read this first sentence. To divide two powers that have the same base, so you need to make sure they have the same base, you subtract the exponents. So look at example number 1. We have c over c to the 11th power over c to the 8th power. Well, if they have the same base, I want to subtract their exponents. So really, I'm left with just one base because I'm combining them, and 11 minus 8 is 3. Okay, so when they look like a fraction, to get rid of it, we have to subtract. If you look at the second example, I have 2 to the 3rd power over 2 to the 2nd power. Well, what's 3 minus 2? 1, and 2 to the 1st power is just 2. Now, somebody last period said, well, could I do 2 to the 3rd power, which is 8, over 2 to the 2nd power, which is 4. So they want to know if I could do 8 over 4. Well, sure. What's 8 divided by 4? 2. You're just going to be doing more work.
Hold on, how did you get 8?
2 to the 3rd power is 8. 2 times 2 is 4. 4 times 2 is 8. Okay? So let's do an example. Number 1. We have two different bases here. We have x and we have y. Let's do x first. So ignore the y's. I have x3 over x to the 2nd. Same base, yes or no?
Yes.
Yes. So we need to subtract their exponents. So 3 minus 2 is 1. So we have x. Thank you. Good, yeah. You can just put x. You don't have to put 1. Okay, what's my next base? Y. I have y to the 4th over y to the 1st, because there's nothing there. So 4 minus 1 is y to the 3rd. Good job, guys.
How you get 3?
Don't get too excited yet.
How'd you get 3?
4 minus 1.
Because
Because y it's to the nothing, like it's just y. Whenever it's just y, it's to the 1st power. Alright, let's do the second one. K to the 7th over k to the 5th. Same base?
Yes.
So k7 minus 5 is k to the 2nd. M to the 10th over m to the 3rd is m to the 7th. Now, what about p?
Would it be P? It'd be 0.
It'd be, well, what's 2 over 2? 1. So p over p just cancels out. So it's not necessarily 0, it's just not there. So it just cancels. So you don't have to write it down. Okay, number 3. X over 7, or x to the 7th over x to the 6th. 7 minus 6 is x. Y to the 12th over y to the 3rd. 12 minus 3 is 9. 9. Good. I'm glad you think this is easy. Okay, copy down the second box. 12 minus 3 is 9. Copy down the second box. If you're done with the second one, you can go ahead and go to the third.
At this time, can we have who's who to the gym for their pictures? Who's who? Thank you.
She said pictures.
All right, box number 2. This is just like our property number 2 from multiplication, just like it. If anything is raised to the second power, we have to raise everything inside this parentheses to the second power, top and bottom. everything. So this becomes 5 to the second power. What happens when I have an exponent to a power and then I multiply it to I have another power? I have to do what?
Multiply.
Multiply. So this becomes x to the 10th, y to the second over
12.
6 to the second. 6 squared is not 12.
What is it? 6 squared?
36. All right.
Can you simplify
Sit right here, Vanessa. I have to distribute that 2 to everything, top and bottom. I have to square everything. I only multiply if I'm multiplying the exponents. Okay?
You say you squared it, so you got square to 6.
Yes.
36.
Yes. I'm not done. I'm not done. I just set it up.
Oh.
Okay? All right, now, Steve. 5 squared is 25. Do I have an x on the denominator to simplify this with? No, so I'm just going to rewrite it. X to the 10th, there's no y either, so y to the second. Now, 6 squared is 36. That is as simplified as I can go. All right, number 5. You need to cube everything in those parentheses, everything in there. So I'm going to cube 3. 3 cubed. X to the 4th to the 3rd is x to the 12th. I need to cube 4 as well, so this becomes 4 to the 3rd. Are y'all writing this down? What's 3 to the cubed? 3 to the 3rd power. 3 times 3 times 3.
27.
27. 27. Is there an x on the bottom to simplify this with? No, so I just leave x to the 12th over, what's 4 cubed? Don't say 12. 64?
Yeah. Oh.
All right. I want you to try 6 and 7. I'm going to walk around to check it. Riley, start copying this down.
You copy the other night?
I want you to try 6 and 7 first, Jacoby. All right, for number 6, we squared everything in it, top and bottom. So we got 2 squared y to the 4th, because 2 times 2 is 4, over 3 squared z to the 6th. Power to a power, we multiply. All right, now let's simplify it. 2 squared is 4, y to the 4th. 3 squared is 9, z to the 6th. Okay, good. Number 7, cube everything in it. 4 cubed x. 3 times 3 is 9. 5 cubed y to the 12th. Let's simplify it. What's 4 cubed? 64x to the 9th over, what's 5 cubed? Can I simplify x or y? All right, y'all copy down the 3rd box?
No, ma'am. I did. Friday did.
Here.
The 3rd box.
Are you caught up with us, Sean? Copy down the 3rd box.
You want us to write any?
I mean, you don't have to. Good. 3. Any non-zero number. What's a non-zero number?
2,
2,
4,
4,
3,
3, 9, 6, a million. Okay.
22.
Any non-zero number. Any of those things we just listed. Raised to the 0 power is 1. 6 to the 0 power. 7 to the 0 power. 8 to the 0 power. Okay. Let's look at example number 8. What is raised to the 0 power in number 8? Just D. So what does D to the 0 power become? 1. So do I really have to write it? Okay. B to the 4th, C to the 2nd over B to the 2nd, C. Okay. Now let's subtract. B to the 4th over B to the 2nd. Yes, ma'am. Yes, ma'am. What's 4 minus 2? Good. B squared. Please go to the office. 2 minus 1 is... Focus, guys. 2 minus 1. 1. So your final answer is B squared C. Okay. Now, question. If I squared, or if I raised everything in here to the 0 power. If I raise everything in here, 0 times 4 is?
1, 0.
0.
You see that?
I said 0 times 4 is 0. 0 times 7?
0.
0 times 3? 0 times 6? 0 times 9? 0 times 3?
0.
Do you see that everything in here is going to be raised to what power?
0.
0. So what is this answer?
0 is 1. You just said that everything would be 0.
Okay.
Oh my, you confused me.
Yes, ma'am.
Would you send intransitive ribbons to this box office?
Yes, ma'am.
Thank you.
Yes, Steve, I did say everything will be raised to the 0 power. But what does this property tell me? Anything raised to the 0 power is what? 1.
Wait, so I have a question.
Yes.
So, this is the next one be 0? No, that's the same.
It wouldn't be 0.
You won. That was hard.
I seen the paper.
Oh my gosh, Jacoby. Get out of here.
I had to. It was right there.
You had to cheat?
Nah, I knew it.
No, you didn't.
No, you did, Jacoby.
All right, write down our last box. Last box, write it down.
I already wrote down the last box.
Good. Pause. This last box is the hardest box.
Obviously, look at that 12. Look at 13.
Those look easy. Yeah?
Oh, you can?
You look at an 88 in that test, but somehow I still got 58 in this class.
In the 0 period, bro.
All my followers can hear your grade.
That's what get your hands. How come you read my grade up?
I'm not going to discuss that right now.
That's kind of weird. I'm trying to pass. You should literally be a grade. I refreshed it 3 times.
It's not even that.
Alright, so the last property and the hardest property. Okay, it's not hard, but out of these 3, it's the hardest. Okay, if I have a negative exponent, do you agree that this example right here, when I put this over 1, it stays the same, right? That's a fraction. It means the same thing. Anything over 1 means the same thing. Okay, well, if I want to get rid of this exponent, this negative exponent, all I have to do is take the reciprocal. Reciprocal means you flip the fraction. So to get rid of this negative exponent, it has to go to the bottom. If I flip it to the bottom, it becomes positive.
Wait, so you like switch the...
So if you have a negative exponent and you switch it, it becomes positive. Okay? So 2 to the negative 4th. Well, if I take the reciprocal of this fraction, which means I flip it and I put 1 on top, 2 to the 4th on bottom, it becomes positive. Yes.
Ooh.
A squared. A squared. If I put it over 1, it becomes negative. If I want it to go back to positive. Alright, so let's look at number 11. The first thing I want you to do every time is I want you to go through here and flip what needs to be flipped. V to the negative third. Where does that need to go? To the bottom. So write V to the third. Okay, what else is negative? 6. Yeah, y to the negative 6. So I need to flip it so it goes to the top. So y to the 6. Okay, now, so I flipped it, okay? Let me rephrase this because I don't think I said it correctly. It doesn't have to be in the bottom to be positive. It just has to flip to become positive. So if it's negative in the top, then if I flip it, it becomes positive in the bottom. Okay, now let's rewrite everything that was original. So v to the third went down. Rewrite wx squared.
Wouldn't those two be negative?
No. Okay, we moved negative 6, so what's originally left from the bottom? W. Alright, now we're back to property number 1, just dividing. Y to the 6 over, there's no y's, so what's it, that just stays. Y to the 6. There's nothing to simplify it with. Which one? Yes, V stays the same. What about W's? They cross out. And then x squared stays the same. Because there's one of each. Okay? If you have W to the 4th over W to the 4th, that is just 1. So it cancels out. Whenever you have the same base to the same exponent, it crosses out. P to the 7th over P to the 7th. Gone. No. Then you have to subtract. 7 minus 6 is... Okay? No, these are great questions. Great questions. Number 2. 12. Sorry. Number 12. What do we see in this one that we haven't seen yet? 32 numbers. 32 and 4. Numbers like 32. Okay? It's a constant. Good job, Vanessa.
That's so mean. I didn't say it.
Don't say it.
I didn't say it.
Because it doesn't make sense. No.
First of all, I said that 32. I corrected you, number 2. Can I get a Jolly Rancher for that?
You want one so bad.
Okay.
I should eat breakfast. I'm a big boy.
Then a Jolly Rancher is not what you need.
Jolly Rancher's gonna help me
Okay.
a lot.
32. 32. Guys. 32 divided by 4 is? 32 divided by 4 is? 8. Thank you, Vanessa. Focus. It's 8. Okay, now that I have 32 and 4 taken care of, let's rewrite to make everything positive. A to the negative 8. Where does it need to go to become positive? To the bottom. Okay, I took care of that one. B to the 3rd can stay. C to the negative 4th needs to go to the bottom. A to the 3rd can stay on the bottom. B to the 5th can stay on the bottom. But C needs to go to the top. Yes? That's A. Sorry.
That's an 8, is it? I put it down. Oh, it's an 8. Whoops.
So what do we do? Just kidding.
I'm waiting on you. Take it off your head. Presley. 32 divided by 4 is 8. Okay, now let's simplify. B to the third minus b to the fifth gives me b to the negative 2. Okay? Alright, so it needs, let's rewrite our fraction. So 8's going to stay the same. B to the third minus b to the fifth. So if I simplify it, okay, it stays on top. So negative, or 3 minus 5 is negative 2. So I've taken care of the 8, the b. Let's look at the c's. C squared minus c to the fourth is c to the negative 2. Stays on top because we simplified it. Now, what's left on bottom? A to the 8th times a to the, what does that become?
8 to the 5th.
No, 8 to the 11th.
11th. I'm not dividing it. They're beside each other and they're being multiplied. So what do I do to the exponents? Add. Okay.
No. I wasn't in here.
8 over, now, we just said that a becomes to the 11th because we add them. But what needs to happen to b and c?
Then you cancel out.
They need to go where? They need to be positive. So where do they go? Good job. Good job. Yes, that's the answer. Do you want me to do another one with you? Okay, let's do one more. The last one. Okay. Let's go ahead and make everything positive. What's 5 divided by 25? 1 over 5. 1 over 5. Okay, j needs to go to the bottom, so I have j to the third on the bottom. K squared can stay. Where does m to the negative 6 go? Bottom. Okay, k, oh, now I'm looking at the bottom. K needs to go up, so k to the fourth, and m needs to go up as well. If they are negative, we swap them, they become positive. Okay, let's simplify. 1 over 5 stays. K2 times k to the fourth is k to the sixth. They're right beside each other. Okay, do I have anything to simplify j? No. So j to the third stays on the bottom. So I've taken care of k, k, j, 5. What's m2 minus m6? M negative 4, but it has to go on top because I simplified it. So when I really simplify this, I get k to the 6th over 5j to the 3rd, m to the 4th. Yes. Do you see why I put m to the negative 4 on bottom? Or m to the 4 on bottom? Okay. So, flip it over. I just want y'all to do 1 through 8, all. 1 through 8, all. Is that between 1 and 8?